Hello everyone, welcome to Coffee Shop Sales, and this is SQL project. In this project, we will solve 10 SQL queries. We are provided by this dataset link. Let's open this dataset link. We will download this CSV file. I already did, so let me close this and open my PG admin. First, we have to create a database. I already did, so I will just give you how we will create the database. So here we will write our new database name. Let me give coffee shop sales. I already have, so it will we do not click on save button. So let me close this. So first we create a table for our data. So we will do this by create table, and our table name will be sales, and our columns will be transaction ID, which will data type of int, and transaction date with date data type, transaction time with time data type, transaction quantity with integer, store ID with integer, store location with varchar, product ID with integer, unit price with float, and product category varchar, product type varchar, and product details varchar. We referred this from this CSV file. If you can see, our transaction ID has in integer form, and date is in date, and transaction time is in time format, and our store location is in string format. So that's why we give it as a varchar, and so on. We have created the table. Now our aim is to copy the given data. So for that we do copy sales. Sales is our table name from, and we give our path where our CSV file resides, and delimiter will be comma CSV header. So now our first question is to calculate the top 5 most frequently sold products by category. Retrieve the top 5 products with the highest sales frequency for each product category. First, we calculate the total sales by each product category and each product ID. For that, we give select product category, comma product ID, and count product ID as sales count from the sales table, and we group this table. We group this by product category and then product ID, and we order by sales count, and we give as descending order. So let me run this. Now we get the product category, product ID, and all sales count. So for bakery and product ID 71, we have 3076 number of sales. So now our next aim is to now we will rank this, you can say, sales count by, you can say, maximum. So for that, what we will do select product category, comma product ID, and sales count, and we will use window function here for the ranking. Row number over partition by product category, order by sales count descending as rank from, and we will give this complete query here. So let me run this. Now you can see we got our ranks, and here you can see for bakery we have 71 is the first rank, 72 on the second rank, and respectively for the coffee we have the same. You can say 21 product IDs for is on rank 1, and 38 is on rank 2, and similarly for the all product categories. Now our aim was to find the top 5 most frequent sold products by category. So we will limit this by, you can say, 5. So for that, what we will do select star from, and we will give this complete, you can say, complete query here, and then we will give where rank is less than is equal to 1. So we will retrieve all the ranks with 1, 2, 3, and 4, and 5. Let me run this. Here you can see our, you can say, for bakery we have these five product IDs with their respective sales and rank. And then for you can say branded, we have these five IDs and respectively for all the product categories. So our next question is to retrieve the total revenue by store in January 2023. Calculate the total revenue generated by each store during January 2023. So first we calculated the distinct, you can say unique store IDs. For that we use select distinct store ID from sales. Also for cross check we use select distinct store location from sales so that we will get the unique store locations. Here you can see uh, store IDs are also three and store locations are also you can say three. So if you look closely, these all are you can say related. So uh, now what we will do, we will filter all the transaction where transaction date is you can say January 2023. For that, what we will do select star from sales where transaction date is between 2023 01 and from you can say and 2023 01 dash 31. If we run this command, we will get all the transaction of the January 2023. So our next aim is to calculate the total revenue. For that, what we will do transaction quantity into unit price. So for that, we will do select store location, transaction quantity, and unit price, and we multiply transaction quantity and unit price and save it as revenue from sales, where our transaction date is between you can say 1st January to 31st January. Let me run this. Here you can get we have store location, transaction quantity, unit price, and our revenue. So now what we will do, we will sum this we will sum this revenue by grouping store location. So for that, what we will do, we will do select star. We will do select store location sum on revenue as total revenue from you can say this command and group this by store location order by total revenue descending. So what we will get our store location and total revenue, and we sort this by you can say total revenue in descending order. Let me run this command. Here you can see we have three stores and with their you can say respective total revenue, and these are in descending order. And for and for uh, and for cross verification, what I have done this complete you can say complete query with respect to store ID instead of store location. If you run this command, here we will get the same results, but here we will use store ID. So our next question is to query the unique product types in Lower Manhattan store. List all unique product types that were sold in the store located in Manhattan. So what we will do, we will find the distinct product type from sales where store location is Lower Manhattan. So select distinct. Distinct is for getting you can say query unique values, and we give product type from sales where store location is equal to Lower Manhattan. Let me run this command. Here you can see we get 29 rows. You can say 29 unique product types, which lies in store location Lower Manhattan. So our next question is to find the transaction before 12 p.m. Calculate the total number of transactions that occurred before 12 p.m. on any given day. So in this we have to just use the where statement. We will use where transaction time will be less than, you can say, 12 o'clock. We will include that, or you can say we will count that. So for that, what we will do select, count, and I use distinct here. You can say if there is any transaction, you can say duplicate transaction. For avoiding that, I use distinct here. So count, distinct, and transaction ID as our total transactions from sales where transaction time is less than 12 o'clock, or you can say 12 p.m. Let me run this command. Here you can see we have 81,751 total transactions which occurred during you can say before 12 p.m. Is to calculate the average revenue per transaction during peak hours and non-peak hours. Calculate the average revenue per transaction for each product category during peak hours 7 a.m. to 9 a.m. and non-peak hours broken down by each store. So first we will calculate total revenue. For that we will multiply transaction quantity with unit price. So for that what we will do, select store location, product category, transaction time, transaction quantity into unit price is as revenue from sales. Let me run this command. Here you can see we will get the total you can say revenue. uh, Now what we will do, now we have to you can say calculate the average revenue for peak hours and non-peak hours. Here we will use our case statement. So what we will do select store location, comma product category, and we have to calculate the average you can say average revenue. For that we will use average here. Now we select the case statement, we will use the case statement. So we start case when transaction time is between 7 and 9, then revenue and as average revenue peak, and comma average. Again we have to calculate this for, you can say, non-peak hours. For that what we will do, average case when transaction time not between 7 and 9, then revenue and as average revenue non-peak. From, and we give this you can say give this query here, and group this data by we will group, you can say, this data by, you can say, store location and product category. Let me run this command. Here you can see we get the average revenue peak for our peak hours and for the non-peak hours for our store location and product category. Here you can, so our next question is to calculate the product with most price fluctuations. Retrieve the product that experience the largest price fluctuations. That is the difference between the highest and lowest price across all transactions. So first we calculate the maximum and minimum price for unique, you can say, product IDs. For that what we will do select product ID, and we will calculate the maximum of unit price and save it as highest price, and comma minimum of unit price as lowest price from sale, and we group this by, you can say, product ID, because we have to calculate this for each product ID. Let me run this. So now here we get the product IDs, and for you can say every product ID we have its highest price and the lowest price. If we you can say subtract this highest price and lowest price, we will get the, you can say, price fluctuation, and then what we will do, we will you can say order this price fluctuation in descending order, and then we will limit it by 1, so that we will get the maximum you can say maximum price fluctuation. Let's go to query. So select product ID. We subtracted you can say highest price and the lowest price. Here you can see maximum of unit price minus minimum of unit price as largest price fluctuations from sales, and group this by product ID over you can say ordered by largest price fluctuations descending in descending order, and we will limit here 1, because we want only one value. So let's run this. Here you can see for product ID 9, we have the largest fluctuation, which is 16. So our next question is to calculate the product sold in every store. List all the products that were sold in every store at least once. So first what we will do, we will query the store location and the product IDs. So for that, what we will do, select store location and product ID from sales, and we group this data by store location and product ID so that we do not get the duplicate product you can say product IDs for the same store location. Let's run this command. Here you can see we get the unique product ID for the you can say each store location. Now, what we will do, we will count the number of product IDs, or in you can say, if our 451 product ID, it occur in how many you can say stores. So for that, what we will do, we will use count statement here. Let's see, select product ID, and we count the product ID as count and from, and we give this you can say this query here, and we group this by product ID having count of product ID greater than is equal to 3. So we queried only the you can say product IDs which has count greater than is equal to 3. Let's run this. Here you can see all this product ID has the count greater than 3, or you can say it is you can say greater than or is equal to 3. Because we have only 3 store, that's why here count is maximum 3. Now what we will do, we have to query only the product ID. So what we will do, from you can say from this complete query, we will give this in from statement here. You can say we give this in from statement here, and we will select product IDs. Let me run this. Here you can see we get only the product IDs. Our next question is to calculate the top 5 days with largest deviation from average daily transaction quantity. Identify the top 5 days where the total transaction quantity deviated the most from the average daily transaction quantity. So first, what we will calculate the total transaction for each day. For that, we use select transaction date, comma. You can say we have to calculate the total transaction. That's why we use sum here. Sum of transaction quantity as total transaction from sales, and we group by this by transaction date, so that we get the you can say total transaction for each date. Let's run this command. Here you can see now we have to calculate the average you can say average daily transaction quantity. For that, what we will do select, and we will calculate the average of total transaction which we calculated here as average transaction from, and we will give this query here, and we will run this. Here we get the average transaction quantity for each day. Now what we have to do, we have to calculate the deviation. So we have to subtract the total transaction from the average transaction, and as it is you can say deviation, so we have to calculate the absolute value. Let's write this query. So select transaction date, comma total transaction, and we use here absolute here. So from total transaction we have to calculate you can say subtract this average transaction. That's why we copy this query and paste it here, and this you can say total transaction minus average transaction will be our save it as deviation, and from, and we give you can say this same query in you can say in our from, and we order this you can say query by deviation and descending, so that we get the largest deviation on the top, and then limit it by 5 because it is given we have to calculate the top 5 days. So let me run this command. Here you can see we have our transaction date and total transaction on that day and the deviation. So our next question is to find the stores with average unit price greater than $2.5. Retrieve the store location and total revenue for each store where the average unit price is greater than $2.5. So for what we will do, we will calculate the total revenue. For total revenue, but we will select store location, transaction quantity into unit price as revenue from sales. So from here, what we will get the store location with its respective revenue. Now now we will calculate the average unit price. For calculating the average unit price, we will use the window function. Let's see, you can say select store location. We calculated here, you can say revenue as we calculated in you can say earlier command. Then in window function we give average of unit price over partition by store location as average unit price for sales from sales. Now we have store location, revenue and average unit price. Now we have to calculate the total revenue. So for that, what we will do, we will sum this. You can say all revenue by and group this by store location. For that, what we will do select store location. We will do select store location, average unit price, sum of revenue as total revenue from, and we will give this complete query here, and where average is greater than 2.5, because it is given we have to you can say retrieve the stores where average unit price is greater than $2.5, and we group by store location and average unit price. Let me run this command. So if you do not want to, you can say retrieve this average unit price, and you want to just show store location and total revenue, what we can do, we will do select store location and sum of revenue as total revenue from, and we give uh, uh, this you can say this query here, and where average unit price greater than 2.5, and group this by store location. The main difference in both these queries is just of average unit price. Here we are querying also average unit price and give also this in group by, but here we have just retrieving store location. If you can see, we will run this command. Here you can see we get the store location and the total revenue. But also here the condition is the same, where average unit price is greater than 2.5. Now we have to calculate the products with the highest average sales quantity per transaction in each store. Identify the products with the highest average sales quantity per transaction in each store. So first we will calculate the average transaction quantity for each, you can say each store location with respective product ID. For that, what we will do, we will group our data by store location and product ID and calculate the average, you can say transaction quantity. Select store location, product ID, average of transaction quantity, and save it as average from sales. Group by this data by store location and product ID. Let's run this. Here you can see we get the average value for all, you can say store location and product ID. Now we have to calculate the maximum average for each store location. So what we will do select store location and calculate the maximum of average from this data which we pasted here, and we will group this by store location. so that for each store location we get the maximum average. Here we get, now what we will do, we will calculate the you can say store location and the product ID which has this average. You can say we will calculate the product ID which has the average value as 1.52915, so on. So for that, what we will do, we will do select store location, comma product ID, comma average from, and we will give, you can say, this query in which we calculated the average. We give it here, and where average in, because we get you can say three values here. That's why we used here in, and we will give this query here, pasted this query here, here, and when we run this command, we will get the store location, product ID, and average. So we get our results. So we have, you can say, alternate way of doing this. If you do not want to use the max function, we will use this by window function. For that, what we will do, we calculate the average as we have earlier do. We calculate the average using, you can say, average quantity, transaction quantity, and group it by store location and product ID. Let me run this. So now what we will do, we will rank all these averages for respective, you can say, for each store location. Let Here you can see select store location, product ID, comma average, comma row number for, you can say, ranking, over partition by store location, order by average in descending order as rank, from, you can say, this query. We pasted it here. Let me run this. Here you can see we get the average, you can say highest average as rank 1 for each store location. Now what we will do, we will retrieve on the rank 1. So we get the three, you can say, three values for you can say here with the three unique store locations. For that, what we will do, select store location, product ID, comma average from, you can say, this complete command where rank is equal to 1. Let me run this. You can see we get the same results from the both the query. Thank you.